Logarithmic spirals are everywhere, from the towering trees to the devastating hurricanes sweeping across the sea, from the starry galaxies to the tiny DNA cells in every organism's body, including yours. While many people may apply a negative connotation to these spirals, thinking, oh, just another math concept I'll never see or use. In fact, if you look around right now, you'll see a logarithmic spiral. Our universe, the Milky Way, is a spiral galaxy in the shape of a logarithmic spiral. Crazy, right? But being back on topic, in this video, I'll show you how logarithmic spirals really do play an important role in this universe through animals, vegetation, and much more. Now, some of you people out there may not even know what a logarithmic spiral is. So, what is it really? So, a logarithmic spiral is a spiral that follows simple growth patterns such as grow 1, turn 1, grow 2, turn 1. It's an ever-expanding spiral that grows exponentially with its angle. The polar equation, which is an equation used to graph it, is r equals a times e to the exponent of b times theta, where r is the distance from the origin, which is 0, 0. Theta is the angle from the x-axis, and a and b being arbitrary constants. Now, as mentioned before, you can find the logarithmic spiral in items such as Romancesco broccoli or everyday hurricanes. But why does it do this? The answer is the principle of parsimony, which is a scientific principle which says that things are connected or behave in the simplest or most economical way possible. Sam Wolf. For example, look at this broccoli, Romancesco broccoli. Instead of being a mass of interconnecting tubes or some other weird shape, it stays together in a simple form, being able to grow while retaining the same shape. Now, another way logarithmic spirals play a role in nature is through the Fibonacci sequence. Fibonacci, another omnipresent presence in nature, can also be clearly traced back to the logarithmic spiral through its relation to the Fibonacci spiral. To explain the Fibonacci spiral, you'll need to understand the actual sequence. Now, for the few that don't know what the actual sequence is, here's a short explanation. The Fibonacci sequence is a sequence designed by Leonardo Fibonacci that begins with 2 ones and adds a previous number in the sequence to get the next in an ever-repeating loop. This concept can be easily demonstrated with the equation f of n is equal to f of n minus 1 plus f of n minus 2. So how does this relate to the Fibonacci, and how does that in turn relate to a logarithmic spiral? The Fibonacci sequence is commonly graphed like so. And when connecting a quarter circle to the edge of every region, it creates a logarithmic spiral, known as the Fibonacci spiral, a spiral whose angle is 137.5, which is also known as the golden angle. Now, this is all cool, but how will this prove that Fibonacci isn't just a useless math concept? Here's an example. Think of the billions of cells in your DNA. What do you think could possibly relate to the Fibonacci sequence? Now, the Fibonacci sequence can be found in the millions upon millions of DNA strands in your body. Every DNA molecule measures 34 angstroms long by 21 angstroms wide for each full cycle of its double helix spiral. George Dvorsky. Now, you may have noticed, but those numbers are all in the Fibonacci sequence. Another cool occurrence is the ratio compared to each other, being 21 and 34. It is 1.619046, which is also extremely close to the ratio of phi, 1.6180339, which is also known as the golden ratio. Now, when phi is graphed like the Fibonacci sequence starting from 1, it also creates a logarithmic spiral known as the golden spiral. Now, as you can see, the logarithmic, golden, and Fibonacci worlds are all very interconnected, along with other math concepts such as Pascal's triangle. But we won't go into all of the deep and dark, since we value your sanity. This is all cool, as we now see how logarithmic spirals affect and shape nature through the Fibonacci sequence, along with the principle of parsimony, among other things. Now, let's look at how animals can use this fascinating spiral to aid in their daily lives. Let's look at a few of the more prominent examples. One is the ram and its horns. These impressive mammals use their huge horns, which resemble various non-coplanar spirals, as battering rams against other rams to win mates. Semi-aquatic or aquatic animals, like the hermit crab or mollusks, use shells that grow in the configuration of the logarithmic spiral. The basis for this, in fact, the biggest cause live objects grow in this shape is to have the ability to grow without losing shape, or to have constant proportions. There are more uses than just the physical ones, however. Animals like hawks and raptors, birds of prey, use it to hunt at high speeds. To achieve the maximum speed, they need to be as aerodynamic as possible. However, when diving with their heads forward, they cannot see in front of them. This creates a quarrel between speed and vision. The bird must find a way to see the prey while maintaining a high speed. Ask Alan. What do you think is the solution? How did you guess? A logarithmic spiral? Am I getting too repetitive? They can solve this problem by flying in the shape of a logarithmic spiral. Using this method, they can use one eye to look at the prey while flying in a mostly aerodynamic form. The logarithmic spiral truly is an amazing concept, one that can be found in many places and forms for many occurrences and uses. While we've talked about how they can be found in nature through the form of animals, plants, and cells alike, we've barely scratched the surface. Thank you for listening. This has been Max, signing off.